Everyone enjoying the conference? Okay. All right, so now I actually get to do something more useful than announcing people. The theme for most of the talks today, in this room at least, have been around best practices of using Anaconda Enterprise, whether it's how to get the most value out of Hadoop and Spark clusters using Livy, to sizing your environment properly, how to secure your environment. And I'm going to take a piece of what Chris talked about in his last section around package management and talk to that today. Most of this is culled from questions that sales engineers get asked in the field from customers. And as I'm going along, I didn't do things in any particular order. If you have any questions or something doesn't make any sense to you, feel free to raise your hand. I've said to you, a few of you already, I am more of a conversationalist and a lecturer, so the back and forth is actually preferable to me. So let's get started. So allow me to reintroduce myself. Duane Lawrence. I'm responsible for sales engineering and solution architecture in Anaconda. I've been here for just under 3 years, and my background before coming here has been in distributed computing, analytics, and actually beforehand I was pretty much a compiled software bigot. Okay? Didn't believe in things like Python were real languages, but I found religion. And a lot of what I'm going to talk about today are things I learned while I was also a part of the implementation team, the team that actually stands up Anaconda Enterprise for you after you've made a purchase or while we're doing a proof of concept. All right, so this is the one marketing-ish slide. I'll apologize, but I think it sets a good baseline here. What is Anaconda, in a nutshell? Whether it's the open source or enterprise version of Anaconda, we're really here to help organizations analyze the information and respond at whatever speed is necessary for their business. Okay? And right now, the interactions are increasingly digital, so you need to be even more flexible than you may have been in the past. And we really want to make data scientists more productive. Okay? Make sure they aren't, you never get around having to cleanse your data yourself, but make sure you don't have to do the standing up your environment yourself, and get the fruits of the labor by data scientists off of their laptops, okay, and out to the end user community. So let me stop here and ask a quick question. How many people here are already familiar, have a working knowledge of Anaconda open source? Okay. And how many are using or taking a very close look at Anaconda Enterprise? Okay, a smaller team. And last question, how many people would call themselves more on the end user data science side versus IT? Okay, all right, so a good mix. And the reason I asked, especially that last question, because a lot of what we do at Anaconda, at least during the sales process, as sales engineers, is we mediate the discussion, or the friendly debate between the end user community getting what they want and IT who's trying to establish control. Okay. So getting back to Anaconda in a nutshell, our co-founder and board member Travis Oliphant had a saying that they started this company in order to help people engage with their data. So and I think what's on this slide is just a more long-winded way of saying that. All right. So practically speaking, how do we help our customers engage with their data? So we'll talk about Anaconda open source first. And as we'll see here, we have Windows, Mac OS, and Linux users. We have the Anaconda repo that's available publicly. We have the Conda Forge repo. Big ups to the Conda Forge team. I think a few of them are here today in the room. And users will use Conda, the package manager, to gain access to any combination of packages they need for their work, and work in one of these main platforms. So we do three things here. And, well, we do more than three things, but I think these are the three most powerful things we do with Anaconda. We provide the easy access to package. If you don't have Anaconda, if you're pip installing, you're going to be building these packages yourself. Okay? And now think about it. You're a data scientist on Windows trying to install SciPy, setting Fortran compiler flags. Not a great use of your time. Okay? We pre-build these packages for you, make them available in our repository. The community, as I mentioned before, Conda Forge, builds other packages. There's some overlap, and they make them available in their repository. And so now you can install packages on your machine in binary form without having to worry about doing any builds. The second thing, dependency management. Okay? You'll have package A relies on package B relies on package C. You install all the defaults, or you try to, but package C doesn't like that version of package A. Okay? And considering you may have scores of packages in your environment, and each package may have a handful of dependencies, that gets incredibly complicated very quickly. Before Anaconda, it was left as an exercise to the data scientist to figure out that package management. Now, Anaconda, particularly Conda, the package manager, ships with a package, with a dependency solver that makes it a one-click, one-command operation now. So instead of managing the dependencies, you try to build an environment. If it can find a combination of packages to solve your needs, it will. If it can't, it will let you know. And we'll talk about a couple ways you can address that in a couple slides. And then there's easy reproducibility. Data science, one of our salespeople loves to say data science is a team sport. We've already talked about how effective data scientists can be, on their laptops. But one, you may want to go back to last week, last month, last year when you did a specific analysis with a specific set of dependencies. Or you may want to have your colleague reproduce the work that you've done very easily. It's not sufficient to simply hand them the Python or R code that you built. They need to know what dependencies are there. How many people have ever tried to run someone else's code only to have the environment puke up on them saying, okay, exactly, all the methods are different. If you're lucky, you just get the pink little warning that says, all right, this will be deprecated, okay, but you've been warned. Okay? So one of the things that Anaconda allows, even in the open source side, is the ability to create portable environments to ship along with your code. Okay. Any questions about any of this so far? I know this might be a review for a lot of people. All right, great. Okay, and I'll call these things collectively package management. Okay. So now let's look at the enterprise. So I mentioned before we try to mediate the relationship between data scientists and IT in the enterprise. And I look at data scientists as working for the business units, trying to get a certain job done, and IT running the environment, but also being really the execution arm of information security and legal and compliance when it comes to the roles and the controls that need to be put into place. And very often we get inbound requests from customers, and it's interesting, a lot of them will come from either end users or IT, and they have matching messages. It's either, hey, listen, can you come talk to our IT guys, please? Okay, they won't let me get access to anything, and I desperately need this to do my job. Or if the data scientists happen to have a little more clout, we'll maybe hear from IT. Please, these data scientists are beating us over the head. They just called a VP. Now I need to figure out how to get them the stuff they need. Okay? And it's incredible how often. Usually when we get inbound requests, they fall into one of those two categories. All right, and so what I'm going to talk about today is empowering, enabling that package management in a way that keeps IT happy, which means it keeps legal happy, which means it keeps information security happy. Talking about how we do package management at scale. Okay? I've already mentioned a couple times, working on laptops. You've deployed, Chris and Daniel talked about deploying clusters. Okay? You've spent this money on this infrastructure. You spent this money on amassing this incredible amount of data. Let's show you how to do package management at scale to all those cluster nodes. Mentioned before, data science is a team sport. Package management is going to be key to collaboration. And as Chris talked about with deployment, package management is going to be key to that. Does all this make sense so far? You good? All right, fantastic. Okay, so the cornerstone of any Anaconda enterprise deployment is the repository. And it's it's table stakes actually for most of our deployments, and it's the piece that allows you to get the packages that we have available in our public repo on site in a way that they can be used. Now, some of our customers will ask, well, hey, can I just install the latest Anaconda distribution and be fine? Okay, we have some customers who start out that way, and that's great as long as everything you need is in that one Anaconda distribution. So, some of our customers, what IT will do is they'll open up the firewall, pull down one version of Anaconda, close it back up, and then say, here it is. You have one version of NumPy, one version of Pandas. Go build something nice, and that could be fine for a while. But eventually, you want to try some new functionality. There's an update to a library. There's a bug that's fixed, and you want some different libraries. And now you have to go back out, get another version of Anaconda, pull it down, and wait, do you want all those new packages or a combination of those packages and the ones that were in the previous distribution? Okay? And so to get around that, what you would do is install the Anaconda enterprise repo on premises. And now, instead of begging IT to pull down different versions of the Anaconda distribution, data scientists can just point directly to the on-premises repo and pull down whatever packages they need from there. And so we can have as many historical versions of packages as is necessary stored there, and then now you have data scientists a little bit more comfortable. But now, how do you control that? Okay? We want IT to maintain ultimate control over what gets into that repository. And actually, I have a couple slides on that specifically in a second. But I want to talk about how we populate this repository. And I'll give another quick survey. How many of us are in environments where you can have a server get unfettered access to the internet to pull packages down? Okay. All right, the Conda Forge maintainers and the crazy USAA guys, okay, can do that. And how many are in like a total air-gapped environment where there's no way, okay? All right, so the majority of those who've answered. So there are three approaches, okay? Chris talked about two of these. The three approaches that we've seen with customers to populate their on-premises repo. Online, air-gapped, and what I like to call proxied. All right, so let's talk about online package mirroring. This is the simplest approach, where things are most flexible, where the IT environment is most permissive, and you're able to connect unfettered to our public repository. Actually, and for some customers, they may not leave this proxy rule, this firewall port open the entire time. They may only open it up once a week, once a month, however often they want to update their packages. But the fact is, you have maximum flexibility with updating your packages going this route. We have package filtering capabilities when you're doing this mirroring process. As I mentioned before, IT is typically enforcing the rules, regulations, and policies put in place by legal and information security, and those typically revolve around the types of packages that are appropriate for your network. So we allow for blacklisting by name or by license type and whitelisting of packages. So let's say, for example, we have one hedge fund in New York City who's a customer who doesn't trust OpenSSL because every 18 to 24 months there's some OpenSSL panic. Okay? So what they do is they build OpenSSL themselves, okay, and blacklist it during the mirroring process. Okay, so now they feel that they can be secure with their OpenSSLs. And you can make these decisions yourself based on your own security profile. Other customers only want packages from us that, we'll provide indemnification for. Okay? Especially customers who are newer to open source and haven't already decided that they're going to accept the IP risks that come with deploying open source. Some customers will blacklist everything that we're not providing indemnification for. And of course, we can do whitelist exceptions. So let's say you're going to block all OpenSSL except OpenSSL of a certain version. You can provide that in a whitelist. Any questions about this? Is anyone already doing this? Yes.
So if I blacklist something after it's already internal,
Yep.
manually go through my local repository?
So the question was, what if you are slow and you blacklist something that's already been mirrored? Short answer, and do you have to go and manually remove it, or will the blacklist kind of get filtered through and it will extract? You'll have to manually remove that package. Okay. Any other questions? All right. So, as I mentioned, in addition to mirroring packages and filtering them by name, you can filter them by license type. This is a list of licenses that are currently that the various packages in the Anaconda repository have. I've highlighted BSD, excuse the public domain typo there, but I highlighted BSD and MIT because they're generally considered the most permissive licenses, and customers rarely block those. What we'll get mostly from customers is like, okay, AGPL and GPL3, absolutely not. No way that can even touch the network. And sometimes customers will block GPL as well. So I'm actually interested, for those of you who have more controlled environments, is it about the security of the packages and potential vulnerabilities that your IT needs to control, or is it about legal compliance and licensing? Licensing? Okay. Security? All right, that's fairly consistent with what we're seeing. Legal gets involved very easy, especially as we're dealing with larger organizations. Okay. And one thing, I should say, when we do, if you are trying to talk to your IT team or legal and compliance or InfoSec about going with Anaconda, we have a fairly strict process, as you can imagine, from where we source our code for these packages through our build chain to where we make it available for download and available to you. Okay? That's something we take very seriously, for our reputation. And for example, I have no account on those servers. I can't log. I can't even smell them. So we maintain tight control there. Okay. All right. So let's talk about Airgapped. So it sounds like a lot of people in the room are in air-gapped environments, and this is where you have a server that's going to be hosting your repository that at no point will be able to reach out to our public repo and pull packages down. Okay. Chris talked about this a bit earlier. In that case, what we do is we provide you with an offline archive of all packages that you can then mirror into your environment. This is clearly the most restrictive environment, and it offers the least flexible update scheduling options. But I did want to take a second to show you what what it looks like. So this is just a quick look at where we store these offline archive packages, and makes it a little bigger. And so here, what you're doing, I had this in the slide deck, you'll download just the packages you need for your particular platform. So if you're just running Anaconda Enterprise collaboratively or just running on Windows, you'd only download those archives. As you can see, some of them are pretty big, about 30. Some of them are 60 gig, some of them are 50 gig. The whole archive of all packages, all versions, is going to be over almost 150 gig. So you pick and choose which libraries you want, pull them over via a desktop or something that has connectivity, and then manually mirror. And even though you're mirroring from a local archive, you still have the same filtering capabilities. So the same blacklist configuration that you had, that you would have if you're doing online mirroring, applies with the offline mirroring. The one thing though is that you do have to take physical possession of these packages, and so they do touch your network. And once or twice, customers have had to get exceptions to be able to do that. All right. Oh, I have this. Excuse me. Okay. So the third option with when it comes to package mirroring is this gateway approach. And this can be seen by some as the best of both worlds. I think it gives you the most flexible control, okay, while still giving you flexibility with how often you can update. So in this case, the production repository may sit on a segment that cannot route to our public repository, but there may be a DMZ segment that can. Okay? And you can chain these repositories together as much as you'd like. So what you can do is place one repo. We can call it the test repo. We actually have one customer out of the UK who calls it their dirty repo. And you can mirror all packages into that, whatever subset of packages, into that. And then at some later date, you can then mirror packages into your production repo. And this can be done for any number of reasons. It can be done simply because there's to work around the network restriction, or you may need to actually evaluate and test the new packages out at this DMZ repo. Okay. As I mentioned before, we take the security of packages, we take chain of custody very seriously, but we have certain customers, we have military customers, we have three-letter government agency customers where there's no level of assurance that we can provide them that's going to make them comfortable enough to install things in production without checking them themselves. Okay. So what you can do here is that since this DMZ server has unfettered access, since this DMZ server has unfettered access to the public repository, you can mirror these packages as much as possible, as often as you'd like, maybe even nightly. And then once there, you can have your evaluator test them. You can do security scanning or even application testing. I have an asterisk there because I have a point to make about application testing in a couple slides. And then once the testing is done, you can mirror over. Okay. And so let's take a look at the approach. You can see here on all these slides where I have, does it have a laser pointer? No. Okay. You can see all these slides, we have this Active Directory LDAP authentication authorization server. The idea is that users can log into the Anaconda repository using their existing creds. In order to have effective gateway mirroring, you want to restrict access to the gateway repo to your testing group. Okay? If your end users could log into it, or even assuming they could even route to it, if they could log into it, that would kind of defeat the purpose. So you would mirror your packages. Thank you, sir. Look at that. Okay, so you mirror the packages to the gateway repo. The screener would run the test on them, and then the screener will tag any of the packages that have passed with the appropriate tag. And I won't pull this up on the screen, but one of the things about Anaconda repo is that one of the things you can do is you can tag any package release. So actually, let me just show it. So here. All right, so if I go to our public repository, and I'll just pick on this Wakari channel, and I'll click into the Wakari server, we can see that they're basically nightly releases or very frequent releases, and most of them are tagged dev or labeled dev. Okay, we can see about 2 months ago there was a release of 4.2.2. Okay? And so basically what I'm saying is that you can mirror all the packages into your local repo, leave them untagged, and then have your tester go in, test them, and then once they're done, label them as screened. And then if we go back to and then from here, you would set this production repo to only mirror from the screen tag. Yes?
Is there any ability or workflow to make changes to the packages while they're in the test repo? Say you want to patch something extra and then have the patched one mirrored in production.
So the question was, can you make changes to packages that are in the gateway repo if you notice a problem, and then upload those, have those mirrored to the production repo? Absolutely, you can do that. You just need to keep track of that as a patched package and understand that the subsequent packages that you're mirroring wouldn't necessarily have those upstream packages, upstream patches. I think right after you did that, the appropriate thing to do would be to submit a pull request to us to properly repair the package. Thank you. Yes. So the question is about Airgapped? Yes.
So how person is it to, knowing that there are more than 1,000 packages, how person it is to actually download each of them in your desktop, build a repository, and then in a local.
So the question was, how much work is it to download those packages? So again, if you saw what I had earlier, you're not downloading the packages individually. What you're downloading is essentially a tarball. Okay. What you're essentially downloading is either all the Linux 64 packages, all the Win 64 packages. So you download that tarball to your desktop, copy it over to the server, and then mirror from there. Okay. Any other questions about Airgapped? All right. So as you saw earlier, I had this asterisk next to application testing. And I wanted to talk a little bit about that. So when is application testing needed when you get a new package? Clearly, it seems like common sense. You got a new package, test your old code against a new package so you can upgrade the package. I do want to talk a little bit more about reproducibility. We talked about it as being key to Anaconda deployments, and particularly Anaconda Enterprise deployments. A lot of what we do in Anaconda Enterprise is about making this kind of flexibility and reproducibility-based flexibility available to end users. So Conda has the ability to create what we call Conda environments, which are essentially distributions of either Python or R that can sit side by side on one machine, and you can switch back and forth between environment or distribution as simply as you would change directories. Okay. And the value here is you can have, say, I'm sure some of our customers, or some of you may have this situation, where there is a blessed distribution for Python in production. Python 2.7 with this version of Pandas, this version of NumPy, this version, and so on. But your data scientist, you may have a harebrained scheme or a very reasonable scheme to try something out new, and you need some of the the async await functionality that comes in Python 3. Okay, so you want to test that out here, or you may just need an updated version of the Pandas package. So you can stand that up on your machine without any kind of interference, causing any interference to or having any interference from the other environment, and every analysis can run in its own dedicated environment. And again, these are very lightweight. You switch from one to the next. It's all about path manipulation and environment variables. It's not like standing up a Docker container. And so now the question is, what type of testing do you need to do? Clearly, you may need to do some security testing because you don't want anything insecure getting onto your network. But you can be a little more judicious about when you do application upgrades and do testing of new libraries against existing code. If it's running fine, leave it that way. Okay? Customers ask us, do I run Python 2 or Python 3? We say yes. Okay? You can have, there may be some practical limits. You won't necessarily want to have hundreds of environments in production, but you can have as many environments as you need to run your different analyses. Any questions about this? I think this is, personally, this is kind of profound to me because I spent most of my career trying to help customers forklift upgrade their applications based on new versions of product or databases or something like that. And I think this kind of flexibility that Anaconda provides you is one of our most powerful pieces of functionality. All right. Yes.
So do you have any optimal how many environments you can have?
Again, I think there may be some practical limits, but there is really as much disk space as you want. And actually, to tell you the truth, it's not even really a disk space issue, because if you have the same package in two different environments, they're going to be hard linked, so you're not going to even double the disk space. I think it's really about, it's going to be a practical thing more than anything else. I have maybe 20 environments running on my laptop. Not a problem, and it's just me. Okay, keep on forgetting I have this thing. All right, so now we've been talking pretty much about the packages that you get from Anaconda. But is anyone here familiar with Conda Build? Conda Forge guys, yeah. All right, great. So the idea here is that you can take your own models, your own analyses, and create Conda packages from them yourself. And when would you want to do that? So again, we talked about data science being a team sport, okay? And we also talked about putting things into production. And there are different definitions of production. And when customers tell me they want to put something into production, I ask them who the end user is. Okay? If the end user is a pure business user, then I know putting something in production means deploying a web application, maybe, or maybe deploying a RESTful interface to a web application. If the end user is someone quasi-technical, well, then maybe you have a run-only Jupyter notebook that they can step through. Okay? They're not intimidated by code, or maybe even want to see the code so you can see your work. But if the end user is another data scientist, then putting something in production is really giving them a module to import. And if you want to version that module and keep track of it, then it's best to create a Conda package out of it. Okay? And so the idea is that for our customers that want to build their own Conda packages, what they typically do, assuming the data scientist isn't a quote-unquote developer, whatever that means, they'll hand the code over to the developer. The developer will follow all the Pythonic processes and best practices, things like making sure it's PEP 8 compliant, running a linter on it to make sure there aren't any obvious errors, depending on what side of the spaces versus tabs war you fall down on, making sure it's one way or the other. And mind you, I think our training people would physically confront me if I didn't make it clear that the answer is always spaces. Okay? Tell them I told you that. And then from there, and also I should point out that one of the things we do as a company is help you define those best practices. How do you create the most deployable Pythonic code? If we go back to Peter and Travis's original reasons for creating Anaconda, it was for data scientists to engage their data easily and quickly with Python and put that code into production. Okay? So we can definitely help you with that. And then once you have your module ready, once it's mature enough and ready, Conda Build, the single command. If it's pure Python, it's literally one command. Okay? If you have dependence, if you're dependent on things that are already in our repository, no problem. You can pull those in. And then once you have the package build, it's another single command to upload. Okay? And when you build your internal Conda package, you version it yourself, and then it'll be tracked in our repository and used for dependency resolution, just like any other package that we would give you. Any questions about? Again, I know I'm asking a lot of questions, but who here is interested in building their own packages? I know that's okay. Is this clear? All right, cool. All right. Okay, so let's talk about some best practices, and this comes out of some questions and some pains that our customers have seen. One thing I would say is always enable access control. We've been talking about LDAP authentication and authorization a bit here, but for some of our customers, let's say you bought a site license of Anaconda Enterprise, and so anyone in the company can get access to it. You still want to enable access control. And this wasn't always the case, but as of about 8 or 9 months ago, we started enabling access control by default for the repository, for a specific reason. So I talked about OpenSSL and that one hedge fund that doesn't trust it unless they build it. Okay? Now, let's play that out. Let's say a vulnerable, like let's say a vulnerable package gets on your network, and you realize it after, say, a month. What do you want to do? You want to understand who downloaded it, who installed it, what server did it go on? Was it just desktops or something in production, or hopefully maybe just QA? And part of the reason you're going with Anaconda Enterprise to begin with the repository to begin with, is to control things. And so if you have the repo and then leave the front door open, you've lost all your logging capabilities. Maybe you can track things by IP address, but it'll be far more effective if you can track by user. So if you have authentication, actually this should say authentication, not access control, excuse me. If you have authentication turned on, okay, then what you can do is if when you get that vulnerable version of OpenSSL on your network, you can check the logs. You saw, Chris showed you how you can just search through the logs, kind of a la Splunk, identify who's downloaded that vulnerable package, and then take the appropriate remediation steps. Okay. Any questions about this? All right. Okay. Now, let's talk about package mirroring. Okay. We've talked about the packages that Anaconda provides. We've talked about the packages that you may build yourselves. And I've alluded to some other channels, particularly Conda Forge. But there are plenty of other channels out there. Customers trust us, and some customers are only going to run packages or install packages that they get from us. But others, Conda Forge, some of these packages are maintained by the original developers themselves. Okay? Bioconda is well regarded in the pharmaceutical and biotech space. And then you have Intel, who took the Anaconda distribution and added some performance enhancements and customizations for their latest chips. So you may want to take advantage of this. And so what happens? You see a package like, yeah, this is fantastic. I want to do this. You're kind of tempted to, okay, let me mirror all the things. Okay. And so now you have a repo that may have 8, 9, 10,000 packages in it. And you may not want to do that. And let me explain why. Okay. Channel conflict. Okay. So is anyone here familiar with Conda RC and what it does? All right, so I'll talk through it a bit. So Conda RC is a .rc file that lives in your root folder that basically defines how Conda behaves. One section of it defines which channels it'll search to access packages. So if you say Conda install NumPy, it's going for this Conda RC, it's going to look in defaults, which is the Anaconda channel. It's then going to look in Conda Forge, Intel, and Bioconda, and it's going to stop the first place it finds it. Okay. So now, let's say you love Bioconda, and Bioconda's build of Scikit Bio, for whatever reason, solves a problem that Anaconda's build of Scikit Bio does not. And that'll happen sometimes with these really vertically specialized channels. They'll do things slightly different than we do for a very, very specific reason. So you may say, you know what, all right, I want that package. So I'm going to put Bioconda at the top. Great. Now Bioconda's at the top. That particular analysis now will will be running with the version of Scikit Bio that you need. Okay? But it begs the question, do you want that version of Scikit Bio for all of your analyses? Do you want everything else in Bioconda to be installed before a similar package would be installed from the Anaconda channel? Probably not. Okay? And then that doesn't even mention Conda Forge, where I think there's probably you could almost call Anaconda a subset of what's available in Conda Forge. So if you mirrored all of Conda Forge and then put Conda Forge up at the top because you wanted one or two packages from there, huge potential for conflict and pain. Okay? So what I would recommend instead is just be judicious about the packages you mirror, and especially the channels you mirror. And so you can look through all the different channels that you trust, all the different channels that you may want to get packages from. Choose the specific channels, or choose the specific packages that are going to be helpful to you, and then mirror those into a channel called other channels locally in your environment. And then you know that in most cases, if I am if there is a channel package conflict between other channels and Anaconda, it's because I expressly wanted that package. Does this make sense? Yeah. Again, this is just one approach. You're going to constantly have to look out for channel conflict, package conflict. And so it's not something you can just set and forget. And depending on your use case, you may need to be a little flexible about how you define this. Has anyone run into this type of issue already? Okay. And so I'll put you on the spot and ask you, how would this approach work for the environments that you've seen where you've had this conflict? Okay. So the response was, if you have a person that knows what to look for and can resolve those internally, of course. So again, this is not, for a lot of customers, they can just use everything from Anaconda and just be fine with that. But once you start pulling things from other channels, you really need to stay on top of it. Thanks. Okay. All right. The last thing I want to talk about is distributed package management. A lot of our customers are running their analyses against Hadoop or Spark clusters, and they want to run distributed Python or distributed R. It's fantastic. You've built out these giant clusters with these huge data sets, but now you've created a more advanced package management problem, because now you need to get the packages on every node. Okay. How can you do that? I guess the easiest way you could do it is to drop everything on a shared drive that all nodes can connect to. Okay? And that'll work assuming you're running a very recent version of NFS, and maybe you're only loading things infrequently and having really long running jobs or jobs that don't change very often. But if you need to load and unload stuff with any kind of frequency, the NFS server can become a bottleneck. The other approaches we've seen really use the management tools that come with the major cloud Hadoop vendors, specifically Cloudera Manager and Embari. And if I go back, the way it works is we allow you, as a data scientist even, to go to your Conda environment, pick and choose the packages you need in the repository, and create either a Cloudera parcel or an Embari MPack. This example is just showing Cloudera at the repo, and it'll be written to disk here. You can then go to Cloudera Manager and tell it to pick it up and distribute it to all of your data nodes or worker nodes. Okay. This works well because the pain that we see from customers very often is, we have one version of Python, one distribution of Python on the cluster, and it takes me a month, to get that upgraded, because the Hadoop admins, whatever, I have to file a ticket, it just takes forever to do. The advantage here is that you can specify using Anaconda Enterprise the specific distribution that you need, the specific Conda environment you need, and you can hand it to the Hadoop admin on a platter, and they can use the tools they're already using to distribute the packages. So they're happy because they're using, again, we talk about us being the mediator between data science and IT, so they're happy now. But there's one mild drawback in that you're still blocked on IT, or excuse me, the Hadoop admins to distribute the environments for you. But at least you're making it very simple for them. Is this something that anyone here would be interested in doing it? I feel like we talk to most of our customers about distributing packages to Hadoop clusters. Okay. Yeah, exactly. So the question was, would it be the same for Hortonworks? Yep, we would create a MPAC here, and Bari would pull the MPAC and distribute it out to the cluster. Okay. All right. So closing thoughts. Package management, it can go anywhere from really simple to really complex, especially when you're pulling things from different environments. I think having a really clear understanding of what the legal and compliance policies are, the InfoSec policies are, and having that up front before you start an implementation is going to be key. And that way you'll save yourself a lot of pain when you try to roll this out into production. All right. I know I fielded a few questions during the conversation, but are there any additional ones?